Hello and welcome to the final pre-June uh, summary plus assignment video on CarolViz. Now, before you skip right to the question you need to do your stock on, watch through this first few minutes because I have a few things to explain. Firstly, obviously, next week goes to past paper assignments. There are much better videos out than that I can make on every single past paper, so we're not going to try and deal with them because there's so many people that have better videos. Just search one of them. Literally, just search up the paper and do it. If you want video solutions, or better, just do it yourself and mark it with the mark scheme. But also, yeah. So what I'm going to be posting, there is extra questions that they post, but those questions just look terrible, so I'm not posting them. And because for section B of the assignment, if you didn't know, you have to do 3 past papers for section A, and then section B you have to do some like follow-up questions which aren't that long at all. Firstly, they're not long, and secondly, the question, and they give like some other questions if you can't find any yourself, because they don't give you specific ones to do, but they give you ones like if you can't find any, or if you don't want to do ones that you can find, they give you some terrible questions to do yourself, which I'm not explaining like 6 questions a week. But also, the last thing, the assignment this week is on uh, differential equations in series only for some reason. So I'm going to explain some differential equations. And another thing, sorry, that wasn't the last thing. So what I'll be posting from now on is probably I'll be posting maybe a couple shorts on just random stuff, and some like revision tips. Just revision, general stuff like that, and then after June, I'll come back to doing the assignments. And on the summer assignments, the 13 assignments, and I'll go to do the core pure, and hopefully if I get in, the FP1 and FP2 assignments. But core pure is obviously going to be the most useful for everyone that does double. Anyway, let's get into it. So oh yeah, talks about the paper assignments. Oh god, I didn't animate this. All right, so hopefully you guys can see my mouse. So I said I would show you guys a differential equation method from second year. Don't skip just because you heard this. It's actually quite useful and it's quite easy. So basically, this is something you learn in second year called the integrating factor. But it's useful here because it makes some differential equations easier. So just to clarify, you'll never have to see this as this last line. You'll never have to use this for the A level, the normal A level. But for the second year, you have to use it, and also it's just helpful. So it's when you have a differential equation in this form, you multiply both sides by e to the integral of p of x, which is this here. So I've given an example, dy by dx plus 2xy equals x, which I think this is actually solvable by, no it isn't. Oh no, this is solvable by separation of variables, but obviously we're going to be using the integrating factor. So the integrating factor is going to be e to the integral of this function here, with respect to x, so it's going to just be e to the x squared. Multiply both sides by it, and you see that here, this left side is just the derivative of e to the x squared multiplied by y. So it's going to give you this, and then you can just compress this entire left side into this. And then now we have this, we can just integrate both sides, and the ddx and the integral will cancel, and all we have to do is integrate the right side, and then it will give us our answer like this. But so you might see me just the main reason I did this is because I use this method a lot of the assignments. So if you don't understand, then if I've never taught you it, how are you going to understand it? So because most of the differential equations are really easy to solve, so but this does make some of them faster. Anyway, let's go straight to the assignment. Right, so we're starting off with some differential equations. So obviously what they want you to do here is divide by 1 plus y and then multiply by dx and integrate both sides, but we're not going to do that, of course. We're going to move it over, do our integrating factor, multiply both sides by e to the x squared minus x, and then this compresses, and actually this is just a complete coincidence, but this left side also, actually no, yeah, but I compressed this right side as well into a ddx before integrating it for some reason, but you're not meant to do that. So you get the ddx of the product, and then you get the d over dx of the, or you're not supposed to do this actually, so ignore this. And then you integrate both sides, and you get your answer of this. And this is actually I didn't even realize this is very similar to oh my god, this is so similar to the example I gave. I did not steal from this. It is incredibly similar. So next we have another, so B, We have this differential equation. So the nice thing about some of the trig ones is that it actually doesn't include e. So here the integrating factor is e to the integral of negative tan, which just becomes cos because the integral of tan is ln cos or negative ln cos. And then you multiply both sides by, I don't know why that's multiply both sides by your cos x, then your integrating factor. Tan times cos is sine, and then the right side is 0, and then it compresses, and then you integrate. When you integrate 0, it just gives you a constant, and you just get y equals a sec x. Part C. Here I use separation of variables. It was much easier. No, it's impossible to use it here because it needs to be p of x times y for the integrating factors to work. So we have this, you get this equation. And then part C, so I just did separation of variables again. Alright, so we've got some connected rates going. dA dr, 2 pi r, dr dA, 1 over that. And then we already have sine 3t, this is whatever k sine t over 3 pi is dA dt, so you can multiply to get dr dt. Then solving the differential equation, just use separation of variables again. And then you get this answer. And then whenever I write BC here, I mean boundary condition, which means I'm substituting stuff in because I can't be able to show it. Again, as I said in every assignment video, I never show enough working with these assignments. Always show more working than me. Use my working as a guideline of what not to do in your actual exam. Like what's because if you think that I'm including enough working, you're wrong. I'm never including enough working unless I say. So and then here, this is you substitute value in. Next, so first of many sequences and series questions. So this is a personal least favorite for me, this topic. So for pure, so it might be a little bit annoying. Given there's arithmetic, well, that means the common difference of both terms are equal to each other, so you can just set them equal, solve the quadratic. And then geometric means that the common ratios are equal, so just this term divided by this term equals this term divided by this term, and then you solve for x. Next, we have this set of equations. You actually don't need this equation. I don't know why they give it. So you know that S12 minus S6 is negative 69, and then S16 minus S6 is negative 175, and then so you can find S16, S6, and S12, and then just solve. And you get simultaneous equations with this, and yeah. You get simultaneous equations because you have this equation, you substitute values in, and then you get two equations that you can easily solve. Next series again, so the common ratio is 3. Wait, what? The common ratio is not 3. The first... the common ratio is 3. So A is AR to the n minus 1, as we know, so A is 5, R is 3. Set it greater than 10 to the 8, and then you get your answer of 16. Did I not? Oh my god, I think we have another classic, what? Did I just... Wait, question 4. Did I just write the answer for this one? Oh no, I just didn't. Oh my god, this is a classic from me where I just forget to do one of the questions. Yeah, that's just unfortunate. Yeah. Alright, next question. Again, do not follow what I... So I did something called a reducible DE, which is not what you're meant to do. What you're supposed to do here is divide by... you're supposed to divide... I think what you're supposed to do is divide by y cubed. Yeah, you're supposed to take away 2x plus 1 from both... take away 2x from both sides, divide both sides by 3y squared, and then do separation of variables. Or not even that, no, you just take away 2x from both sides and then multiply both sides by dx, and then you integrate. Ignore what I did here. Question 7 is literally just the same as 1D, so I don't know why they put it in. Well, at least I think it is from... Yeah, it is. And then question 8, more sequences, so U7 is 6, so you have this. U5 plus U10 is 16. Do this, get your thing. Part B... some S20 is 1070, and then U5 plus U10 is 65. This literally just tells you the information. There's no modelling, no words, just pure maths, which is nice and easy. So we can just do our equations. solve simultaneously. It's a lot of simultaneous equations in the series questions. And then for part B, S30, just put it in the formula. Question 9, really speed running this. So, this was really annoying, this question. No, it wasn't. I'm thinking of a different one. So, A is 32. A out of the 4, because that's the fifth term, is 162. So you can find R by dividing, and then finding the third term with that information. Next, so you find UN, then just find U10. That rhymes, nice. And then you say when it's greater than 10,000. So when the term is greater than 10,000, UN is greater than 10,000, and then solve and you get N, and then the value of N is just, I don't know why this is parted, because this would just be a 1 mark thing at the end. Question 11, there's a lot of series questions here. So again, find UN, find S5, find S5 and then divide it by 10, because it says they get to keep 1/10. Part B, you have to set what the hell? That is not the correct answer. Well, no, it's the correct answer, but it's not how you get the correct answer, because it should be it should be Sn equals that big number. Sorry, I don't know what I've done here. Is this even right? Question 11. It is right. I don't really know what I've done here. Highest prize is that. Yeah. So that should not work. It should be S. It should be S20. I don't know why it's no, sorry, S20. It should be SN, not UN. So I don't really know how that worked. This is just sheer coincidence, I think. I have no idea. I think you're supposed to do SN here. Differential equation again. I used separation of variables. It was much easier. Oh, wait, no. Wait, oh, yeah, I did do separation of variables here. But you had to use some intuition by parts. Again, if you want to know how to do this method, comment, and I'll upload a show about it. Question 13, separation of variables again. Boundary conditions, cool. Question 14, this is nice. Another differential equation, just partial fractions this time. Boundary condition again. Very, very repetitive. A bit section B. It's not much different, unfortunately. Spoiler alert. Question 15. This is really not very interesting at all. It's just UN, SN, solve, and then you get your answer. Alright, section B. We got some really new stuff here. It's more serious than differential equations. So, we know the difference is 7 for this sum, and therefore the sum of the last 40 terms. We just say the difference is still 7, but now A is just U61 of this series, and then you just find S39. Question 2. Yeah, it's just, so you find UN, find U10, then use S10, and then part B, do sum to how many terms? Sum to n terms, and then solve for n. Nice. Question 3. This question took me way too long. It should not have. So A is 2000, obviously, because the value of the smallest share is that, and then you put it into the formula, get this weird quadratic, and then you solve for R. For some reason, from here I switched to thick writing, which does look a lot better, to be fair. So this is just a normal differential equation. Normal, very standard separation of variables. Yeah, cool. And then just substituting values in. This is a classic one, so the integrating factor here is e to the kt, because you're different. It's with respect to this variable, not the top variable. So the integral. Oh my god, the integral, the e to the integral of k dt is just e to the kt. So you multiply both sides by e to the kt, you get this, and then you solve. Next, you substitute values in. Cool. And then you substitute more values in. Question 6, I don't know why they were... This feels like it should be a model question, but like I don't know why my news came up there. It feels like it should be a model question, but it's just pure math. It's just like, oh, coordinates and differential equations. So you do this, solve, and then boundary conditions. They made you do simultaneous equations now, but it doesn't change much. Next, we have ar squared is 144, ar cubed is 108, and so you can find r by dividing, and then square root it. Oh no, not square root, so just simplify it, and then a substitute, and then find u5, then find s infinity, and then that's your answer. Next, find the first three terms, substitution, sum to infinity, substitution, evaluating that sum, it's just S10. Yeah, it's just S10, I don't really know what that's about. It's just in sigma notation. U16 is 15, S16 is 288, solve, blah blah blah. Yeah, cool. And then find U11, yeah, cool. Question 10 is, again, it's just, it sounds boring because it is boring, it's just the same question over and over again. It's just un sn dy by dx, and that's it. And then substitution, it's just boundary conditions and substitution. Anyway, so this question 10, find un, find u10, find sn, sn equals 7,800, find n. Got another differential equation. You can do some more integrating factor that I've done here to get this equation. Substitution, just remember it's 3, because we're saying it's tripled, so it's 3x0, so you can divide by x0 and it gives you this. Wow, another DVD. I think we've had every iteration of like d something over d something equals k times the thing, maybe positive or negative k, or root, or k root something. So solving the differential equation, cool. Boundary conditions, cool. Or not even that, it's just kt equals then 2, you just substitute the values in. Just remember half, because you already find out that a is 4,000, so the initial is 4,000, so half of the initial is just 2,000. Yeah, cool. Sum to infinity is 288. First and second, so a plus ar is 270. And then you can solve, find r. That took, I don't know why that took so long. Shouldn't have. And then 2 more questions until we're done with our normal assignments for the next few months. This is just the common differences are the same, so you solve. Part B for S41, just do the thing. Find A and D and then do S21, 41. Part C, show that Sn is always a square number. This is actually quite an interesting question. You should write a final statement here, but again, never trust my working. But by the way, for this, you just substitute the values in, and then it will turn into just 9n squared, but just 3n all squared. Cool, yeah, this is another differential equation, so it's inversely proportional to x. Solve, separation of variables, turn into new constants, find your constants, blah, 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 and then you substitute. Oh, no, sorry, you let x equal 0, and then that gives you your answer. And that is it. We are done with normal assignments until June the 20-something, the late June, and we're on to past papers. I wish everyone good luck, and I hope you guys watch my videos until then, but I don't blame you if you don't. But if you're not going to watch my videos until the assignments come back, I will see you in July and summer whenever you check my videos next, maybe even in second year. But yeah, I'll see you then. Goodbye.